Hi there. I'm a retired Intel Xeon engineer, and way before that, digital equipment alpha microprocessor engineer. And today I want to do a follow-up video of the previous video I did, or a series that I did, of building this server. And towards the end of that, in part 3, and I'll link that in the description below, I did some detailed benchmark testing of the various different parts in that. And today I want to focus in on a couple of those benchmarks related to the CPU. Let's take a look at that to remind what they were. Now in this first slide you can see on the screen I was running a test of building the Linux kernel. While you can see the results are around 45 seconds, and that's pretty on average with the type of the CPU that I have, what I really want to focus our attention in is more of the temperature side of the CPU. Now this is temperature is monitoring the hot spot or the highest core temperature in the CPU. We can see a peak of 84 degrees Celsius and an average of 70, and here's the waveform. Now the test was run 3 times, so that's why we see 3 humps right here. And while 84 degrees Celsius is not completely unreasonable, it's a little on the high side for running this. Now in the second test, the C-Ray test, the point of this one is to really hammer the CPU, to keep it as busy as it can. So by that I mean it doesn't have many idle cycles trying to read things from memory. We want to keep everything in the cache within it that are really short to heat up and using all the threads and that. And the results were bad. You know, the average 285K is 19 seconds. This particular system was getting 16 seconds in that. But if we look at the temperature, we can see it was running really hot at over 100 degrees Celsius. And that was pretty consistent on the all 3 attempts on it, that with an average of 83.5. When I built this server, I used a tower air cooler, in particular the Thermalright Phantom Spirit 120 SE. And in terms of the thermal material between that air cooler and the CPU itself, I used the Thermal Grizzly Kryosheet. Now both of those things I've read good things online in terms of review, in terms of keeping the CPU cooler, and since I wanted to keep this server build kind of simple in terms of maintenance point of view, I decided to give that a go. But seeing how their profile on that C-Ray was over 100 degrees, I thought we'd use this video to explore if we can improve upon that. So what I'm going to be doing in this video is try a whole bunch of series of different experiments, from varying the different fan profiles to trying a different set of fans itself that are more towards the static pressure, and then even try a liquid cooler on it instead of using the air cooling in that. And then finally I'm going to try some different thermal paste on these different products and that. And we're really going to sort of explore to see what can help improve upon the temperature of the CPU and kind of settle in on what I find best to use. But before I get started, I wanted to take a pause here and first show you the current air cooling solution that I have inside this case. Now this case, by the way, is a Silverstone RM52. Now here are the exhaust fans on the back of the case. You can start with the power supply itself. It's actually pulling air from inside the case and exhausting it out the back. The Silverstone case that I use came with these other exhaust fans I have. One is a 140mm case fan that's right behind the CPU itself, and then there are 2 80mm fans in a special cage that's right above the PCIe slots that's meant to pull air right behind the GPU. Next you can see the fans that I use that are intakes on the front of it. We have a total of 6 120mm fans, the Noctua A12 25 fans. And they're kind of in a 2-stack configuration. We got a lower set of 3 that's pulling fresh air right in front of the case towards the bottom if you look at some of the inset, and then we got another set of 3 that's right, it's kind of set a little bit higher, scooping air more from the top side of the front of the case and that. Finally, we can put the tower, or the CPU cooler, in the middle of the case here. The air cooler itself comes with 2 120mm fans, and they're kind of sandwiched in between those fins and meant to really pull air across them. Now in terms of the fan controller, the way I have things programmed, I really have it as 2 different sets. We have the orange set, which is based on CPU usage. So those set of fans are going to ramp up in speed as the CPU usage goes higher and higher. The green set of fans I have set towards a thermal probe that I have inside the case. In fact, I placed the thermal sensor near the back side of the GPU. And the idea here is as that sensor gets hotter, or as the GPU starts working hotter, then the second set of fans kick in and they start bringing in even more air into the case and out the back through those 80mm cage fans. The series of experiments that I'll do throughout the various different solutions that I try, the first one is just to run the way I have the curve as it now. I would expect the green fans probably aren't going to be coming on that much during this experiment, so the experiments of the benchmarks are more pushing the CPU, they're not really working the GPU, so I would expect those fans to be idle or even off. The second experiment will be simply to turn the tower fans on at its maximum speed and see what effect that can have. The third experiment will have all the CPU fans, the intake, the tower, and the exhaust all at its maximum speed to see what effect that can have. The last test will just simply turn all the fans on to its maximum speed. Okay, so with that, let's get started. So I'm not going to change any of the hardware right off the bat. I'm just going to run those 4 experiments with the current configuration and the current fans that we have. Okay, before we jump into the results, let me first describe what I have on the screen in terms of the slide configuration. We have our title of which particular set of experiments we're going to be focusing on for a given set of results, and the fan details. So this shows us what particular fans were used in what particular location. Down below is the graph which will show our results. There are 2 indices on it. We're going to show both the CPU peak temperatures in Celsius over here, as well as benchmark results, or will be in seconds. Oh, before I jump there, I should say that all the temperature results are normalized to an ambient temperature of 22 degrees. So what that means is if the room temperature or the ambient temperature was really 22.5 degrees, then I'm going to take all the temperature measurements and reduce it by 0.5 degree Celsius. So with that said, here are our first set of results with the original fans. And the red lines we can see up in here are our peak core temperatures in that. Remember, while we're running the benchmark, we are looking at the highest core temperature and recording it. And in the case of the peak, we're just simply showing what was the highest we've seen across all 3 runs of the benchmark. And of course, the C-Ray test testing the entire CPU is going to give us some of those higher temperatures versus the Linux compile, which is more or less a single-threaded test. The orange lines are the average peak temperatures in that. So once again, we're recording the highest temperature of all the cores while the benchmark's running, but now we're showing you what was the average of all those recordings across all 3 runs of the benchmark. And then finally, we have our benchmark results itself. This is our Linux compile, more or less they're all the same at 48, and our C-Ray test, which is more or less all the same at a little over 16 seconds. So, looking at this in general, I see a bit of a downward trend when we have the fans just constantly at the maximum. There is a bit of margin of error, but I think it's safe to say when the fans are running and more fans are set to just continuously running a maximum, there is a slight improvement in the peak core temperatures. Okay, it is now the next day, and I thought it would be a good time to open up this case and start changing some of the hardware solutions or cooling solutions and see what kind of effect they have. The first thing, we're going to start out very modest. We're just going to change the fans that are on the CPU air cooler, that air tower, to these 2 Arctic P12 Max fans. Now the idea here is the P12 Max fans are known for having a really good static pressure rating. So by that I mean they're very good at overcoming resistance to push air through, in this case, the fins of the tower cooler in that. So the thought process is perhaps these fans can do a better job of getting more air through and cool it faster than the original fans that came with the air tower. Let me change the camera angle so you can see what I'm doing. The first thing I got to do is get access to the tower fans, which is under this big graphics support bracket. You just got to take off these 4 screws holding it down, and I'm I'm just going to lift this up and just kind of slide it gently over like this, exposing the fans that we have on the tower. Now the fans are held on by a simple bracket. Let me use a screwdriver to kind of help me a little bit here. And we can just simply slide it then up out of the case here. I'm going to need these support brackets for the new set of fans, so I'm going to actually remove them from the fan itself so I can transfer it over. The fan is still attached to the motherboard, this wire down inside. Now it's kind of hard for me to reach down there and grab it at the moment, so what I'm going to do is just set this aside for now and work on the second fan, because I have a feeling once this is out I'll be able to reach down there better and disconnect the fan. Okay, and then now I can get my hand down in here and disconnect the fans. And here's the second one. Now I have the new Arctic fans. There's not much in the box. It's just a fan with the PCM wire attached to it and a set of 4 screws, which we don't even need in this case since we're using those brackets. We have to orientate the fan to be blowing in the right direction. We want the air to be going towards the back. So like all fans, what you do is the showy side with the sticker is the place where the air is going in, and the back side where we have these extra support arms are where the air is going out. That's almost universally true. These days you can find some fans that are designed to be reverse flow, but by and large you're going to find that most of them work that way. You know, they have basically a little hook on the side here, and they just hook right into the hole. Same thing on the other side, like that. I'm going to, in fact, do the back one first, because if I do the front one first, then I won't be able to get my hand down in here and plug things in. So it's more or less flush, and then we just pull these bracket so it's tight, holds it tight up against the fins. There we go. And then the wire itself goes down in. That's one. And now let's do the second one. Now before I put this on, I do need to plug this in, because otherwise my hand might have a hard time reaching down in it. Alright, now with that all in and the wires all nice and neat, we can carefully rotate this back to its position. With that done, I'm going to put the lid back on, plug it in, get into the BIOS, and let's now run our 4 different curve configurations with this new hardware setup and see what kind of results we get. Looks like these P12 Max fans in the tower actually had a nice effect. You can see the temperatures are definitely improved over the original fans that are over here. They're more or less flat across all the different curves we have, with maybe a slight improvement once we have the max or the fans on the tower turned on the max by itself. There's only one little anomaly right here, and that's probably margin of error. So this is a positive sign that these fans definitely improved over the fans that came with the air tower cooler. Seeing that downward trend is a little bit encouraging. It does suggest that moving to fans that have a higher static pressure rating may actually give us a little better results than that, at least in the tower. And again, I'm not overly surprised by that, because if a fan with it's going to overcome resistance is going to shine, it's going to shine in that position, because we got those air fins of the tower right next to the fan trying to block the air coming through and that. But let's go ahead with the next step of changing out the rest of the fans to the P12 Max and see where that leads us. First thing I'm going to do is actually do the back one, since this one's pretty easy. Luckily the M2 heatsink is just one of these quick release mechanisms, so I'm going to clip that and take it out. And now with that removed, hopefully I should be able to reach my hand in and remove the fan wire. Let's put the new one in its place. I prefer a black fan, but it actually doesn't really matter too much because this isn't meant to be a showy case. So I went with whatever was available on Amazon at the time when I did the order. The back is now done, so next we have to do the front fan. So let me slide this out this way. The first thing I'll do is tackle the fans that are on the top here. It just unscrews like that and lifts out. Not too bad. We have the case out, and you can see we can get at the screws right here and replace the fans. Now, I said it in my build video that I really liked this Silverstone case because it made it easy to work with, and I think it's showing its once again its features when just replacing parts. So the way I'm able to get at the different fans here without too much trouble kind of showcases that. This was connected to a three-way splitter, so I had the motherboard connected to this one extension coming in. It came out and went in this three different directions to the fans. So I'm just going to disconnect them all from the three-way splitter, and now we can swap them out for the P12 fans. On second thought, before I jump into putting fans on the top, and I have really good access down here, why don't I go ahead and address those bottom fans first. Again, there's an easy feature on the front from this case to give access. So if I take off the front filter, I can actually there's a few screws up in front here. So with those two screws removed, then there's tabs. I just push it, and now this thing drops down and can actually be fully removed. Once again, I've got a triple splitter on this, so I'm going to disconnect the triple splitter on it. And now we have an easy way to remove these three fans. So let me go ahead and replace those three. Let me get the three on the other bracket and then reverse install everything. And that finishes our installation of all the P12 fans. So we now have the P12 Max on all 6 positions on the front, the 2 tower, and the exhaust on the back. I'm going to finish connecting this up, put the lid back on, and we're going to run the experiments on those. Here are those results. Now from my eye, it looks mostly unchanged from the previous one, with maybe an ever so slight improvement over the previous, just the P12 Max on the tower. We're talking like a half a degree or something like that. Once again, we got a few peaks on here that seem kind of an anomaly. Maybe they're a margin of error, maybe it has to do with the timing of when certain temperature checks are being done. But I think in conclusion we can sort of say that this is more or less the same as the previous setting. Alright, thinking about the results where the P12 Max everywhere really didn't give us much of an incremental improvement, I guess I'm not overly surprised by that. The other fan locations that we have inside the case doesn't seem to really have, in my eyes, a lot of resistance to overcome. Yes, there's some fans that have to go through the dust filter on the front, but I think that's not as much resistance as it is trying to push through the cooling fan tower. So that's probably why most of the gain we saw with the P12 Max fans or the static pressure rating fans is going to be had right there in the tower position. Okay, that's enough for today. Now that we're done with our testing on the air cooling, I wanted to move on to try liquid cooling and see what effect that can have on it. And I'm going to be using an all-in-one. This is the Arctic Liquid Freezer 3. It's 360 millimeters, and this is actually the Pro version. It's not the RGB kind, because since this is a server box I'll never see. I don't need the light show inside it if I can avoid it. Let's take a look at what's inside the box of this liquid cooler. So this is an Arctic Freezer 3. It's a pro version of their 360 millimeter fans, so 120 millimeter fans. It's all in one, so this is the plate that would go on the CPU itself, and the pump that's inside it, up to the radiator and the fans. Some of the accessories that came with it are in front of it. The first notable one is when we do install this plate on the CPU. This is a magnetic top that goes on it, and I'll show you later. And it actually has a fan inside it, and that makes it a little unique in that it can cool the components around the CPU, namely the voltage regulators. And that some of the other accessories that come with it, it comes with the bracket and the hardware used to install it on an AMD processor, so I won't be using this. This is used for the CPU or the Intel processor. Interesting enough, it comes with a contact frame. This could help make it flatter, the plate on it and that. So we have to remove the bracket that's on the motherboard, and they actually send you a tool to help you remove that because it has special screws, and then it has the hardware to attach this one. Some other accessories, it does come with a little tube of MX6 thermal paste, a couple different wires. It kind of depends on whether you want to control the VRM fan, the fans on the radiator, and the pump at different speeds individually, or whether you want to control it all on a single wire to have the speed be the same across them, so you have that choice. Extra hardware for attaching this to your case. One thing I want to note about putting it in the case, and that's kind of very important for any all-in-one, is you have to remember that when it comes to bubbles in the system, or air in the system I should say, then there will always be air inside here. You will never have a case where you're completely full of water and it stays that state forever. There will always be some air, either from the manufacturer, a small amount, or some that develops over time. And you want to make sure, all air rises to the highest spot. So when you install these all-in-ones, you don't want to put it such that the pump, which is built into the side that attaches to the CPU, is your highest point. Because as you can imagine, air would flow into here, it would build up inside it, and now the pump is not pumping liquid, or at least, in the worst case at all, in the best case, not effectively, and making a lot of noise, and it could cause premature failure of the motor itself in that. So you always want to make sure that this side is your highest side. Now ideally, you would want this side to be the highest. That way all the air kind of flows up to this side of the radiator where the hoses are not attached. It can go this way if it has to. It just might mean that there's some more gurgling noises possibly up on this side. Now let's go about installing this liquid cooler in our case. As I said, we want to make sure the radiator is always above the pump. And if you think about the case I have here, I really have two different orientations. I could have it in this orientation where it's up on its feet, or I can have it flat in this orientation where it's inside the server rack and that. So when I'm installing it and thinking about keeping the pump lower, I need to consider both of those orientations. This is what it looks like when it's up on its feet here and that. So just to kind of orientate you, this is the front of the case right here. Air's coming in. This is where the CPU socket is underneath this tower. Right here you can see the tower cooler, and the GPU is up on actually on the top with our power supply down below. So in that particular case, we should be okay, because no matter where I put this radiator, the radiator is going to want to go either in this set right here or in this down below further. And in either case, we can see the top of where the radiator would be is above where the CPU is in that. So imagine, I'm running the tubes, I'm running the tubes down to the bottom side here, and then the radiator sticking up. So everything's good. So that would be ideal, because then any air would actually settle on the top of the radiators right here where there's no pipes attached to it. But if I lay the case down and we look at it in that orientation, and let me just kind of hold it up instead of laying it down, we can see that now the lower fans on the front are maybe about this. Maybe if they're higher than the CPU once we get the pump on it, and that it's only going to be slightly higher. In fact, so the lower hose, we imagine a hose going in and running down this way inside it, and the lower hose may actually be lower than the pump itself. So that would not be ideal. There might be some air that gets into it. So because of that, I'm going to install the radiator on this inner bracket, because this one, no matter what, is higher than the CPU and the pump. I think the liquid cooler, putting that in, is going to take more manipulation inside this box. So I'm going to go ahead and remove this bracket entirely. Next, we have to remove the tower on it. So the tower is held on by, if I can point with my screwdriver, these two screws here and over here. So we just need to unscrew those to relieve the tension, and we should be able to lift it right out. Remember, I have the Kryosheet on underneath it instead of liquid paste, so it should be an easy removal. Now I'm going to undo the screws on this a little at a time on each side. That way we're relieving the tension evenly. Alright, I think we have them fully out. I'm going to carefully lift it up. And it looks like the Kryosheet is actually still attached to the bottom of the air cooler and that. So I'm going to have to get that off so I can reuse it. I don't really want to grab this with my fingers and try to pry it up or even squeeze it with tweezers, because from what I've heard it's fairly fragile, and my fear is if I try to grab a corner and lift it up, I might end up cracking the sheet along the lines in that. So I'm going to try to use this plastic. So I'm going to take this and I'm going to attempt to slide it underneath as such, like that. I'm going to set that there for a second and cut myself. Actually, I'm just going to go ahead and cut this piece in half. I'm just going to kind of push it to the middle here. It's got a little bit of a static cling to it. And then, like I said, I'm just going to put this on top to sandwich it and to protect it. Now the first step of putting the liquid cooler on there is to install this bracket on it. It wants to go right here on the CPU, around the CPU. However, the first thing the instructions say is to remove the motherboard provided bracket that's holding down the CPU. The idea is it's being replaced with this more plate on it. But in order to get that off, the first thing you got to do is take the thing off, and these two metal brackets on the side are part of the air cooler. So we need to remove these two. Now, the instructions that talk about installing this, when they say we remove this outer thing, you want like a backer on the motherboard that keeps the other side, the back side of this thing, from falling through. So they recommend putting the motherboard on like some piece of card or something like that. Now in my particular case, since I have the air cooler stuff attached, when I remove it, already has a backer plate that these things are screwed into. So that backer plate happens to also straddle across the back side of this. And there's also stickers on it that's actually holding it to keep it in place. It was kind of convenient for the air cooler to do that, so that way you weren't fighting gravity of potentially falling out. So I think I'll be in luck. While I won't and meaning I will be able to install this without actually removing the motherboard from the case, which is a good thing. The bad side is that I won't be able to extract out the back side of the air cooler. So if I wanted to use that in a different case or a different situation, I won't be able to, because part of it is still inside this case. So depending, someday I might actually have to remove the motherboard and retrieve it, but for now, for this testing, we're just going to leave it in place. But I do have to remove these metal brackets here, so let's start with that. So there's one removed. Now the other one. Now there is a question about these blue spacers. Should I leave those in or remove them and that? And if I look at the frame, if I kind of place it down in here, it looks like I'm in luck that those spacers are not in the way. And I think the pump will stay out of the way itself. We'll find out that in a little bit. But for right now, I'm going to operate under the theory that it's not going to be in the way. So, but what I will do is perhaps put these screws back in to hold the spacers in place, and at the same time holding the back. So now we just want to put in this plate. And the way they say to go about doing it is first release the tension on the CPU, just like this. Okay, relieve the tension. Just going to open it up. And then we can take the screws off that are holding these two things in place. And that's where this comes into play here, and that this came with the Arctic cooler. You can see it's like a little star pattern at the end on the thread, and that's what kind of the screws are on top. So I'm just going to put them in. It doesn't seem like they're very tight. And then the same thing on the other side here. Alright, now we're ready to install this plate. Now the plate has an orientation arrow. I don't know if we can, maybe if I hold it in front of the camera here, you can sort of see that arrow on that side. That wants to go the same place where there's an arrow on the CPU. So it wants to go just like this. And now we can get out the screws that came with the cooler and screw this down, hopefully. Now I'm just going to barely start it at first before I do any real tightening. So I'm just going to make sure each of them reach the point where they're snug. And now I'm just going to tighten in a cross pattern, so a little on each side to make it all even pressure on the back plate. Alright, that seems pretty good to me right there. I'm going to now put the actual radiator and the pump inside the case. I think I'm going to start with this front bracket. I've already removed the fans from this bracket. This thing goes inside here right on top of that. I'm going to go ahead and install the radiator on here first outside of the case because it's easier to do. Now, one thing I want to point out is when I install the radiator inside here like this, we have to take into account the direction the air is going to flow. Now the front of the case is on this side over here. The air is coming in and traveling this way. So I want the air to go this way on the radiator. And right now, the way it comes from the manufacturer, it's set up to what they call exhaust mode. So the air is going in on this side and blowing across the radiator. So what I need to do is move these fans from this side of the radiator to the other side so it's blowing in this direction. So that's what I'm going to do now. I'm going to swap the fans around and install the whole thing on this bracket and put it in the case. I think I ran into a bit of a complication here in that while trying to get this radiator placed in its position, I was running into a problem where the back of this radiator is right up against this GPU card. Here's the problem I have. If I measure from the back where the fans would be touching to the edge of the graphics card right here, I get 60 centimeters in length. And if I look at the radiator and the fan combined and I measure it, it looks like it's approximately 63 millimeters in length. So essentially I am 3 millimeters too thick to be able to fit this radiator and fan combination inside here. A couple ideas that I can do to make it fit in here. First of all, we can have these fans on the outside. Alright, I moved the radiator over here just so you can visualize it more with the fans on the other side. So this would be pulling. So fresh air is coming from this direction. These fans are going and pulling the air through the radiator and across here. I mean, ignore how they're currently mounted. Just imagine I have the fans orientated that way to get the airflow through here and that. Also, the hoses would be on the other side. So I'm just helping you visualize it for temporarily for the moment right here. So what I could do to make this work, as I was saying, is we could remove this fan. So we'd have the two fans as they are over here, and where we have the space behind the graphics card, we don't have any fan. And in that case, I have 25 millimeters of extra space, and now there's a gap between this and the radiator, the cooling setup. Now obviously that's not ideal. Two fans instead of three should have some kind of effect of the cooling and that. So another possible idea is again keep these two fans as they are and remove this fan, but put back in its place a slim fan. A slim fan is typically 15 millimeters in width instead of 25, so that gives me 10 more millimeters, and that should give me approximately 7 millimeters of space between where the fan would end and where the GPU would be involved. Another possible orientation would be putting the radiator and the fan right here on the very lower front 360. Which works just fine. I mean, there's nothing in the case that would unaccommodate here, and there's room for the hoses to go underneath the power cables. It seems to all work out just fine, so now we can have the full-size fans. The one problem I have with this orientation is right here, the hoses. The height of this hose is up from the pump, since they're sticking up, is really close to the same height as the top of the radiator. And ideally you want the radiator to be the highest point. So what I'd be worried about is where air bubbles would collect right here on the bump that's coming up from the radiator. So let me show what I'm kind of talking about here outside the case. Alright, so as you can see, I have some problems, and I can't just put the liquid cooler in here as I would imagine. So there's lots of different choices in that. Again, is having the fans in a pull orientation versus a push, having only two fans, having a slim fan on it, whether I want it up or down. Down I have to worry about air bubbles. If you look at all the various different YouTube videos and that, they all recommend the radiator be higher than the pump, and that we can see. And they like to show, all sorts of things about the radiator and the pump in this orientation, and this is fine, and this is fine. And if we flip it around like this can be fine too. They all are pointing to make sure the pump is lower and the radiator is the high point. But what nobody really tends to talk about is, what if you have a situation where the hose is your high point, like this? Does this actually lead to the air bubbles inside the hose, or is this a case where velocity of the water itself is going to be able to overcome that and push the bubbles into the radiators. Now, I have some custom liquid cooling, and in those cases I do have radiators that are at the top of my case and reservoirs that are lower. And obviously the air collects in the reservoir. And I've seen cases where there's a bubble sitting up here in the tube, and if I turn the pump on full force, I can watch the bubbles flow down and enter into the reservoir. So my suspicion is air is going to collect in a space where it has room to collect and the velocity is relatively low. So maybe in a situation where, if imagine everything was level, the pump and the radiator was completely level on this and that, and there was no high point, where are the bubbles going to go? Are they going to constantly flow around? My theory is they probably wouldn't. They would probably collect over on this side, because as the water comes through and comes down, it would slow down because there's a thick area and multiple choices of where it can go and collect into here. So maybe it could work down below even if the hose was even with the top. But before I make any final decisions about how I'm going to mount this and that, why don't I just do some various performance tests on it. Now, let's try the fans in a push configuration, in a pull configuration. Let's try 2 fans. Let's try it with the slim fan that I bought, and see what kind of differences I get in performance. Maybe those numbers will help us make a decision where we're ultimately going to put this in the end. So why don't I go ahead and mount this onto the CPU. I'm just going to leave the radiator sitting out here on top while I do those tests, and let's take a look at that data. So let me get the pump connected to the CPU. So the first thing I'm going to need to do is attach the wire, the control. So this, I'm going to use the one where I can control the pump and the various fan, the VRM fan down here and the radiator fans all separately. And that goes in there. And then next they show it as sliding up the space right here on the side. Purifier bottle. Put a couple drops down here on it. And then I'm going to use a lint-free cloth to wipe up any sort of oil or residue on it. I'm going to reuse the Kryosheet on it that I previously took off. So I'm just going to kind of try not to manhandle it too much. I'm just going to slide it down. So I took this protection off the plate, and then we are going to screw this down in. So I'm trying to get this done in one shot so I'm not maneuvering the Kryosheet too much. So I'm going to give this a couple turns and try to do even torque on each side. I'm turning it so it was tight, but I reached the point where it seemed like it was bottom out, but I didn't really crank it after that point because I don't want to make sure I crack or do anything on this. So that's pretty good there. Next, we're going to hook these wires up to the motherboard so we can control the various fans. They say on the side here, you can sort of see this one says pump, this says VRM, this says fan. So in my particular case here, we have the regular CPU fan. This is going to be the radiator fan, followed by the pump, followed by the optional fan, which I'll use as the VRM fan. And then finally, the VRM fan itself. I can take off the little protective thing on the top. Interesting thing about this one is this fan doesn't actually turn. The fan's actually, I don't know if I can show it, it's down here inside it, so this is more for looks. But this goes in the orientation this way, and it's magnetic. We just move it down like this, and it is in. Been a few days, an Amazon order some parts and a haircut later. I did finish all the testing of the AIO radiator with different fan configurations outside of the case, so let me show you those results. I have those results in a similar slide as the previous one, except this time while we're running the same benchmarks, the Linux and the C-Ray, I don't show any benchmark results because we're focused more on the temperature, and you can see the index C right here on this side. For the peak temperatures are in red and the average temperatures are in orange as in before, and if we start out with the push configuration where we're pushing the air through the radiator, you can see those results. Now I switch the fans over to the pull configuration. Here are the results, and I would say on the peak side they're relatively equivalent as the push, but when we look at the average it's maybe slightly elevated. Not a lot, a degree at most, I would say. When I removed one of the fans, there was a noticeable bump in the temperature as expected, because now there's a third of the radiator with no air going through it, and that the peak temperatures had the biggest climb of over a couple degrees or near a couple degrees, where the average is maybe a degree higher than before. And interesting enough, when I add the slim fan back instead of the full one, we mostly recovered. The average and the peaks are back to what the original pull had. Those results are pretty much giving me the confidence that it's okay to place the radiator on top and make that room for the GPU, and that I won't have to compromise and try to force the radiator in the lower position so I can keep all the original fans and risk having the pump or the pipes higher than the radiator and having trouble with the bubbles. So let me change the camera angle and I can show you what I have installed and how I have it in its final configuration. You can see the radiator installed right here on the top bracket, but I did have to take these little clips that are holding this out of the case first, install the radiator, and then slide these in. And I had to do that for a couple of reasons. First, normally the way the case is designed, the bracket wants to go in at an angle and then tip back. But in this case, since the GPU is so close to the edge here, we didn't have enough room to angle it, so I need to come more straight down. The second problem I ran into is the width of the radiator does fit in the bracket, but it was just ever so slightly too wide to fit in between these two wings. So luckily what I was able to do is lower the radiator a couple millimeters from the top of this overhang. That way I can slide those wings across here underneath the bracket and then attach it both on the screw point here and then the screw here. It's nice that Silverstone made it such that these wings can be removed or even moved to a different position, because it made it possible for me to do that. We can see now with this installed in here, the pipes are coming off to the side and down to the pump, so the pump is definitely lower than the height of the radiator, and in fact even the pipes themselves, this peak right here, is lower than the top. So this is a safe configuration such that if there are bubbles in the system, it's going to collect inside the radiator, probably on this side where the velocity of the water is going to be the less. So this is pretty safe. So this is when we have our server inside a rack in this horizontal position. It's all good. So, but this case does let you have it up in a workstation configuration. So let's take a look at that as well and see how that works. We can see the pump inside here. You can see it here with the fan is lower height than the top of the radiator. The pipes are on the bottom, which is ideal. So if there's any bubbles in the system, it's going to collect up here at the top of the radiator and not be an issue. With that slight diversion done, and now that we know the radiator is all in its place and installed, I can go ahead and do the final installation of this bracket again, get the cover back on top, and next we can go about doing our original testing, which was trying different fan configurations and different fans to see what kind of effect it has on cooling, except now instead of air cooling the CPU, we're going to be using the liquid cooler. Let me first show you the 3 different experiments I'm going to do now that I got the liquid cooler inside it. So this is a diagram to show you all the different fans associated inside the case. At this point, all the orange fans are associated with the CPU cooling and is controlled by the CPU usage. This is what I'm going to call the curve experiment. And the one big thing to note here is that since I now have the cooler up on the upper bracket, instead of the earlier air cooler, which was pulling the CPU air from the bottom set of fans, we are now using the top set of fans to pull the air in, and the bottom set has been switched to now be the GPU, which are all the green fans here, and they're controlled by a temperature probe on the back side of the GPU. So as the GPU gets hotter, they get faster, but since these particular benchmarks I'm running in this video is focused on CPU, we would expect those fans to be relatively slow or off. In terms of the pump, I'm just going to leave that as a constant 80%. I'm not going to vary that in any way based on usage or temperature. The next experiment, we're going to maximize the speed of all the CPU fans and just hold them on the max for the entire run of the benchmark. And then finally, the third experiment is when we're going to have all the fans in the case running at its maximum speed. With that said, let's take a look at our first set of results. So you can see our previous 3 air cooling results, and now we've added our liquid cooling. Then this first set of runs, we just have the original test. We've gone back to the neck turret, fans on the front for the GPU, and we have the original fans as shipped with the liquid cooler, with the exception of that Silverstone slimmer fan that we had to use in order to fit it in the case. And right off the bat, before we even compare the different curves, we can certainly see a big drop in temperature from the air cooling in that. So that's very encouraging to see, and in some ways kind of surprising. But looking across here, if we look at the curve versus the 2 positions of the max, we can see that there was a nice, as in the air cooler, we saw there's a nice temperature drop when we have the fan set at max. Modest on this particular one, the Linux one. On the C-Ray, there was a couple degrees drop on the average. You can see in the peaks, though, we're looking at almost a 4-degree drop for the C-Ray and perhaps a couple degree drop for the Linux testnet, with one anomalous reading here. In the next experiment, I have changed out the fans that are on the radiator. Instead of being the fans that came with the radiator, I changed it to the P12 Max fans. Of course, I had to keep the slimmer fan as is in order to keep the radiator in its position. And with just that change alone, we can see what the temperatures look like on our 3 different curves. And in this particular case, it doesn't look like there is much of a change at all in my eye. It looks more or less flat or equivalent of what it looked like with the original fans on there. And that, you know, in maybe if you squint a little bit, you can see an ever so slight increase in temperature versus the original fans that came with it. So that's kind of curious. That suggests that those fans that come with that cooler are actually pretty good about getting the air through the fins of the radiator. And then finally, I have changed all the fans in the case over to the P12 Max or the P14 Max fans. You can see once again these 3 temperatures. Not surprising, when the fans are set at max, we get a little better temperature than the curve. But once again, there isn't a large change in temperature with those switching to the fans. They're more or less equivalent. So I think the bottom line we can say across all these 3 experiments is large change by using liquid cooling and some modest change when the fans are set at a more constant fast speed in that. But more or less they're kind of equivalent whether we had the original fans in the case or whether we switched to the P12 Max. So I would say the conclusion of these initial tests that I run with the air cooling and liquid cooling, if I was going to go with the air cooling, I think my final hardware configuration would be to switch out the air cooler, the air tower fans to the P12 Max, but keep everything else at the original fans that I had. And if I'm going with liquid cooling or the AIO, I think all I would change would be just the AIO and keep the original fans, including the fans that came with the liquid cooler, with the exception of that slimmer fan, once again, because I needed it for the radiator. So there we have it. Now we can see what kind of fans I would use if I'm doing air cooling and what kind of fans I would use if I was doing liquid cooling to try to cool this 285K. And we can probably end this video right here with that knowledge and that. But as I sometimes would say, why achieve when you have an opportunity to overachieve? So with that said, up to now, I've been doing all the testing with the Thermal Grizzly's Kryosheet as the interface between the cooler and the CPU itself. But what if I change that? What if I use the Arctic MX6 thermal paste instead? Or the Thermal Grizzly's Duranaut? Both of these get good ratings currently as thermal paste. Would that have an effect on changing? So let's go ahead and take a look at that data. And after that, I might have some bonus charts for you to look at as well. Let's take a look at that data for the thermal paste or the thermal interfaces. You can see on this chart we essentially have the same curves on the fans. So I did the same, run the curve or set the fans to the maximum speed as before. Now the major columns here, what they vary is whether it's air cooling, which is this first three, or liquid cooling, which is this next three. And then from there, this would be air cooling using the Kryosheet, air cooling with the MX6 thermal paste, and air cooling with the Duranaut thermal paste and that. And then the same three on the liquid cooling side. And taking a quick look at this data, essentially, in my eyes, if I focus just on air cooling, there isn't a lot of variance of changing out the thermal interface. Maybe if we squint really hard, we can see some measurements that are lower on the Duranaut thermal paste, but it's not a large amount. I mean, if it's anything, it's probably just a degree Celsius. On the peak side of things, it looks pretty flat to me. I'm not seeing much of a change across them all. On the liquid cooling side, I think we can probably say similar. Like, focus your eyes here on the system max. So this is where we have all the fans set at their maximum speed across the test bench, and we look at the average temperature here. And now we look at it for the MX6 and we look at it for the Duranaut. They're all relatively the same. I mean, it's hard to say any variance of a half a degree or something is anything more than the margin of error. Now, the same thing for the other benchmark. This would be the Linux and this would be the C-Ray. And then in terms of the peak temperatures, if I look across, there's a little variance here of a couple degrees, but again, there might be sort of a margin error measurement on that. So I think bottom line, maybe there's a little bit of the Duranaut over here on the air cooling and that, but I'm not seeing a huge change. And this isn't a surprise to me because I wasn't expecting the Kryosheet to be that far different than the thermal paste themselves based on everything I read. Alright, another thing I wanted to focus on in another charts is up to now I've been showing all these charts with the benchmarks more or less saying I keep getting the exact same results. And the index over here basically has each line be 2 seconds. But what if we zoom it a bit? What if we change this so it has more granularity of it? So this would be the Linux kernel, and we're looking at the bars here across it. And what's surprising to me is that there is a bit of a reduction in the time it took to run 3 copies of the benchmark for the Linux kernel compile using liquid cooling versus air. You can see perhaps on average over here is maybe 0.1 or 0.2 seconds in that. So that's surprising. It's not a huge variance, but it is surprising to me that this actually showed a bit of a change. And if I were to show you the same chart for C-Ray, it's not as prominent. In fact, now we're on multiple lines being just 0.1 seconds in that. So we're talking about an even smaller change. But nevertheless, you look at this, these bars do tend to be lower than the air cooling. So that tells me liquid cooling did improve our benchmarks a little bit. Not a ton, but a tiny bit. Another thing I wanted to look at is how about the average peak core frequency. So take the whatever core is running at the fastest speed and record that in a given time. And what was the average frequency across the test bench? And the blue line is the Linux compile. And we can see, I put a trend line on it, but basically what my eyes is saying is that when we were liquid cooling, that the average frequency of the CPU or the fastest core was actually a little bit higher, maybe 50 megahertz higher than when we were air cooling in that. Not a ton, but enough to say it's statistically interesting compared over here. Now on the C-ray test, we can't quite say the same thing. Remember, the C-ray is where we're running all the cores at maximum speed, and that, in my mind, in my eyes, these numbers are all over the place, and there really isn't much of a trend to say whether liquid cooling was better or worse than the air cooling that. I mean, I plotted a trend line here, and it shows a little bit going down on the liquid, but I don't think that's statistically interesting, and it's counter of what we saw in the last chart where the benchmarks were running a tiny bit faster. Here's a more detailed look of the frequency over the course of the 3 runs. So this is the Linux compile, this is the C-ray, and basically what this is saying on the C-ray side, it's more or less flat. So in the meat of the benchmark, remember we're running the benchmark 3 times, so when we're in the meat of the benchmark, the frequencies was the same on both I think it was 5400, 53 or 5400 on both liquid and air cooling. The really variance is in between the benchmarks where we're ending one and starting the next iteration, or up at the beginning where we're setting up in that. So perhaps there really isn't much variance at all if we only concern ourselves with what's going on in the benchmark. On the Linux compile, on the other hand, it's mostly the same. We can see a little bit of variance here towards the end of the compile, probably when it's switching which files it's compiling. They're mostly the same in there. Liquid cooling does seem to maintain the higher speed. It's not dropping as much, at least here and here, as it did on the air cooling. And we can see definitely some differences in between as well. So that gives you a more detailed look of what was going on. So I think the bottom line is, for single core applications, there was maybe a little bit of a lift on the maximum frequency when using liquid cooling. Finally, I wanted to show another temperature chart. This time we're focused on another component on the motherboard, in this case the PCH chip in that. And the reason I wanted to do that is because changing the way we cool the CPU may have an effect on the other component in the motherboard. If you think about it, an air tower is pulling that air across, and the motherboard around it might be getting some benefit of the air, whereas in typical liquid cooling, when you attach just a pump to the CPU, there isn't a lot of airflow around the CPU. Sure, you're getting water on the package itself, but what about the rest of the motherboard, what it's seeing? Now in our particular case, the Arctic cooler, it actually has that VRM fan, so it's kind of blowing more air. That's one of the features of it, is to blow air on the rest of the motherboard. And if I look at this, squint my eyes a little bit, you can see on liquid cooling that some of the temperatures we saw in PCH was a little less than what it was in air cooling. So maybe perhaps there is a bit of, and this is both peak and average, there is a bit of a benefit of that extra fan blowing on the rest of the motherboard. And then one more thing I wanted to show was, what about the power draw of changing out this hardware? Change the chart a little bit. Instead of drawing one line that bounces up and down and all these different fan control configurations between max of the curve, and then I drew separate lines. So the blue line are all the curves across the different hardware we use for the air cooling versus the liquid cooling in that. And this is when we set the tower max, where we set the fans to the maximum speed on the air cooler tower. We don't have that liquid cooling because we no longer have a tower with fans on it to do that. And this is where we had all the CPU fans set to maximum, and this in the red is when we had all the fans set to maximum. And of course, the more fans we turn on maximum, the more power it's going to use. That's why we see a rise in, this is idle power, so this is when the system's doing nothing. And we can also see on the liquid side there's a bit of an uplift compared to the air cooling side. Well, that shouldn't be overly surprising because we added a pump to the mix, and pump's going to use some more electricity. So you can see here the actual wattage of what it is in idle. The best answer of the default fans running on a curve where, when the CPU usage is really low, the fans are at lowest speed, we're a little above 70 watts. Whereas in the worst case scenario where we got the liquid cooling, so we got that extra pump, we got all the fans set to maximum, then the idle is a little over, maybe around 102 watts in that. So there's about 30 extra watts on that, or almost a 50% increase in idle power usage in that. And depending on what solution you pick, you can sort of see what additional uplift that would be. So bottom line, across all these different tests, for my system, I would choose liquid cooling with the original fans using the Duranaut thermal paste. Now on the thermal paste, the only particular reason why I say Duranaut is not because I think it was that much better, it is mostly a lazy answer because that was the last thing I tested, and by just sticking with it I don't have to take it apart again and clean it and put the Kryosheet on it. But if I had just to choose, I'd probably just stick to the Kryosheet because it has less maintenance down the road. In terms of the curve, I think what I'm going to do is I don't want to set any of the fans to maximum 100% of the time because I don't want to take the extra noise and take the extra power. But I think what I will do is change what I did on the curve. Now the curve I said was based on CPU usage, so the higher the CPU runs, the faster the fans run, and that was the default curve that the motherboard had. So what I think I'm going to do is bump it up. I'm going to change it so the fans minimum is 50% instead of something lower that it currently has, and change how fast it will go up to close to the max or 100% based on usage in that. So that way I'm more aggressive. I'm getting the fan faster, and I can find some benefit that's somewhere in between the max all the time and the original curve I have. So I think by going with this additional hardware, what I see as positives over what I originally had. The system is somewhere between a 5 to 10 degrees Celsius reduction in the peak. We saw that on C-Ray there was a big change when we went to liquid cooling, and the average somewhere around 2 to 5 degrees Celsius reduction. The PCH temperatures, or the rest of the motherboard components, seem to be benefiting from that VRM fan, so maybe a slight reduction there. The benchmark scores, we saw a little bit of a reduction on it, 0.1 seconds, let's say, when going with liquid cooling, and we also saw the frequency, the average core frequency, go up a bit using liquid cooling. And in fact, it is a cheaper solution. So if you were to cost out, as of in October when I looked at these prices, the prices of the Noctura fans and all the ones we needed versus just the liquid cooling, you can see there's actually a bit cheaper just going with the liquid cooling. And of course I had to buy the extra slimmer fan in order to fit. If I didn't have to buy the slimmer fan, it would be even cheaper still. Some of the negatives is I'm going to need more power, the idle, because I'm turning some of these minimums up in that. I estimate it's probably going to be about 10 watt increase. If nothing more, the pump itself adds a little bit to it. But in my neck of the woods at 35 cents per kilowatt, I estimate this is about $30, $31, say, a year more for this idle speed. And then finally, I'll probably have to at some point change the Duranaut if it dries, if and when it actually dries out, and if it does, I'll probably go back to the Kryosheet. And so ends my epic journey of how to cool my 285K. Again, these were my results that I got with the experiments that I did. Different people might have different ideas about how to go about doing it, or they might have slightly different results, and that's okay. But, I was satisfied with what I can do, and it certainly helped guide me to what I thought was the right solution for my needs. and that. If you feel strongly that this video had way too much content than necessary, or too little, or just right, feel free to give me feedback down below in a comment. You might be surprised to hear that I probably cut at least half the footage to fit it in the time that you see right now, and it even surprised me of how long the video turned out to be for the subject that it is. All right. So, as always, I hope you found this entertaining, if not informative, and barring those two, maybe it cured your insomnia. And for those of you that made it to the end, I say thank you, my friends, and I hope to catch you in my next video.